The safety of air travel has been at the forefront of a lot of travelers' minds recently. But in a lab on the University of Maryland's campus, researchers have been testing out ways to make flying safer for years. WMAR 2 News' Elizabeth Worthington visited that lab today, where she got an up-close look at some of the technology that could help with a phenomenon called spatial disorientation. What's that all about, Elizabeth?
Yeah, this is the first time I ever heard that term, but whether it's by designing an algorithm to be used on a mind-reading headset or on a haptic suit that's often worn by video gamers who want to feel what their avatar is feeling, this team of researchers wants technology to be there when their other senses fail them.
Which way is up and which way is down is a question no aircraft passenger ever wants their pilot to be unsure about.
So spatial disorientation is a particularly dangerous scenario. What the pilot perceives may not match reality.
Although spatial disorientation is only to blame for about 5 to 10% of all general aviation accidents, according to the FAA, a staggering 90% of those accidents are fatal. Investigators believe the pilot in the helicopter crash that killed Kobe Bryant experienced spatial disorientation when he flew into thick clouds that day. It was that crash that inspired aerospace engineer Dr. Umberto Saetti and a team of researchers at the University of Maryland to develop this technology.
Now I moved forward 2 months, and so the haptics is indicating that I should move back.
He's wearing a suit that provides haptic feedback or touch sensations across the body. A pilot could use the signals when their visual cues aren't available, like when they're flying through fog.
But say that I start drifting to the left, like I am right now. Then I'm gonna feel a sensation on my right arm that's gonna indicate to roll back to the right in order to go back to the point where I was. I was able to recover the aircraft by just trusting the haptic cueing sensations that I'm feeling across my body.
The research team here at UMD is testing the tech using a virtual reality flight simulator before it's introduced to the real world. They're also testing out different uses for pilots on gadgets like this headset that could potentially measure a pilot's stress levels.
For example, if the pilot is experiencing high cognitive workload, then the aircraft flight control system can take over a little bit more.
It's not about automating the entire aircraft, but augmenting the pilot's perception in a high-stress or low-visibility flying environment.
Applications are really endless, and I don't think we even thought of enough applications yet, because new applications come every day.
So that headset and that haptic suit are a little clunky for a pilot to wear. The goal is to one day have wearable sensors that are a little bit less invasive.
And this is so cool for the younger generation who's already involved in these video games and knows. So when do you expect that this would be a real world application for this?
Not for a while. So he said for technology like this, it usually would be about 10 years at least from when you start researching. He started about 4 years ago, so we still have several more years to go before we see this in military pilots or commercial pilot use.
All right, Elizabeth Worthington, thanks so much for that report.